This machine walk-around covers the Tigercat skidder line, focusing primarily on the 610, 620C, and 630C grapple skidders. The 630B model, which was equipped with the original hydrostatic drive system, was the lowest cost per ton skidder available. The new generation of Tigercat skidders utilize electronic control technology combined with Tigercat's hydrostatic drive system. This allows Tigercat skidders to operate at variable engine RPM, automatically increasing engine speed when additional horsepower is demanded. The new models use 20 to 30% less fuel per hour than the previous models. Now, Tigercat skidders have the lowest fuel consumption per hour and per ton. The engine compartment has a clean layout with clear access to the engine service points. The 630C has a forward tilting engine enclosure to easily access three sides of the engine. The hood enclosure forms a sturdy work platform. The hydraulic components are separated from the engine and the accompanying high temperatures. In the event of a hydraulic oil leak, it reduces the risk of hydraulic oil spray onto the engine. Hoses and wiring are optimally routed and clamped in place. This reduces the chance of leaks and arcing. Belly pans provide access to the drivetrain components and make it easier to clean debris from inside the machine. The component layout optimizes service access and keeps hose and wire lengths to a minimum. All of these factors combine to create a tidy machine layout and make service and maintenance easier. Cooler operating temperatures reduce maintenance costs and increase machine lifespan by reducing heat-induced stresses placed on the engine and hydraulic system. Tigercat skidders run cooler than all competing brands due to larger heat exchangers and better airflow systems. The 630C is equipped with a hydraulically driven automatic variable speed cross-flow cooling system. An automatic reversing cycle cleans debris from the heat exchanger area without exiting the cab or halting production. Because the fan speed is thermostat controlled, the fan will only turn at the speed required to keep the engine and hydraulic oil temperatures within optimal range. This results in improved fuel economy, quicker cold weather warm-ups, and quieter in-cab noise levels. The 610 and 620 skidders are equipped with optional flex air fans, which also have a purge cycle. It's a common myth that a hydrostatic drive system is more costly to replace than a mechanical transmission. The total cost of the two drive motors and the drive pump is less than the cost of the transmission used in any comparably sized skidder, and the procedure is accomplished in less time. Diesel engines produce maximum horsepower at a certain engine speed. With a power shift transmission, the operator is constantly trying to find the right gear to achieve this RPM. Too often, the engine lugs down, or the RPM is too high, and productivity suffers. The hydrostatic drive eliminates this problem because the gear ratio is infinitely variable. A power shift skidder can only produce maximum tractive effort at the optimal torque output speed of the engine. Taking off from a standstill is problematic because the operator has to rev up the engine and consequently increase the wheel speed to get the desired tractive effort. The result is excess wheel spin. With hydrostatic drive, maximum tractive effort is available at any engine speed. The result is less wheel spin and improved performance in soft ground. Tigercat skidder operators need not be concerned with shifting gears to regulate engine speed. Under heavy loads or in difficult terrain, the machine will smoothly and automatically decrease wheel speed and increase torque. The operator simply depresses the drive pedal. Because the hydrostatic drive system allows for smooth starts, shock loads on the drivetrain are minimized. The result is longer life from drive shafts, universal joints, and axles. Hydrostatic braking virtually eliminates reliance on the heat-generating wet disc brake system. When the drive pedal is released, braking occurs automatically, and the machine momentum temporarily drives the motors and recycles energy. The front and rear differential locks are independently controlled.